yesterday is well, we have very small population. Well, this is the introduction of like what is sample proportion. We use the example as the population is very small and the total number is given to you and without replacement. And every time you pick one, the next time the probability of selecting that thing will change a lot because, for example, there's only 8 goldfish, 8 redfish, and if one redfish has been taken, the next time the probability of taking a redfish will be 7 or 15. So the probability change a lot. Just do an easy example. Miss Politic give this example to the class. If I have 10 candies on the desk and I have 4 white chocolate and 6 black chocolate, and I like white chocolate a lot, and if I go away and you just quietly pick one, like white chocolate, and when I come back, will I realize that? Yes, I will realize there's a like obvious reduce in the white chocolate, right? But now what we're going to talk about, well, this is why we need to use the NCR thing, okay? Why we need to use the NCR, because without replacement will make a big difference. It's not a binomial distribution. Binomial distribution need replacement. So we don't have replacement because every time you pick one thing, I can observe that and it's a very obvious decrease in probability for that color. So what we will talk about today is when I have a large population. That's make more sense for me, okay? This makes more sense for me because otherwise why we need to talk about sampling? If I totally have 16 candies on my desk, why we need to talk about taking samples to investigate on proportion of one color? There's no need of doing that. So now for this, start from page 3, okay? Start from page 3. What I will talk about is large population. Okay, this is unknown population. Like, I don't know what's the total number of 17 years old girl in Australia. So it is large population. Also, the population number is not given to you. Okay, think about that. I have a bag of chocolate on the desk. Well, maybe say 200 or 300. And have some white chocolate, some black chocolate. Well, I like white chocolate. Say there's 100 white chocolate and 200 black chocolate mixed together, put here. And I go out, you pick one white chocolate. When I come back, will I really realize that? No. Okay, I'm not going to directly see there's a decrease in the number of white chocolate, and it's hard to realize there's a decrease in the probability of picking a white chocolate compared to when I left the room before I left the room. So in this case, think about that. Even though it is still a without replacement question. Okay, it is still without replacement. You take this chocolate, you eat it already. There's no way to replace that back. Think about 17 years old girl, like in Australia, and I pick one girl. Let's say I'm trying to investigate the 17 years old girl who's over 160 centimeters. Okay, I want to pick a sample of 10. I pick one girl, put it in this room, pick another one. I'm not going to replace her back. Okay, I'm not going to replace her back. But think about that. When I pick one, I'm not replacing that back. It's not going to change the probability that obvious. Well, for example, I have 1 million. Okay, I have half with over, like let's say assume, okay, half over 160, half not over 160. I have picked one who's over 160 already. Okay, I have picked one who's over 160. Well, this is over, this is under. So the total number of girl who's over 160 has reduced by 1, right? And then over 1 million. Is that probability will be very different compared to a half? No. Okay, it's not going to be very different from a half. So that's why the probability we can assume when this is a large population, what we can assume is it's not going to change a lot. Okay, the probability for my next selection of that particular thing I'm interested in is not going to reduce a lot because the total number is too big and the number of that thing I'm interested in is very like a lot. When everything reduced by 1, the total probability, the probability of picking that for the next selection is not going to reduce. Well, it is reduced or increased, like I don't know, but by very, very, very little amount. So we can ignore that. Okay, we can ignore that. Just same as the candy, like chocolate question. There's 300, and when you pick one, I'm like almost can't find that unless I really count that. So almost can't realize that I'm still assuming there's a third of the white chocolate and 2/3 of the black chocolate. That's the advantage. We can do this easily. We don't need to use NCR in this question because there's no replacement. Even though there's no replacement, but we still treat the probabilities the same as the first selection. When you reduce one from the huge population, it's not going to change much. Will it change? Yes, it will definitely change, but change maybe after 10 decimal places, like very little amount. So we still assume for my next selection, the probability is still P. And in this case, this question will change into a binomial question. Okay, this question will change into a binomial. Why we can't use binomial for the previous two examples? Because the total number is too little, and when reduce one is too obvious, and the probability changed too much. I can't still assume the next selection is still P. But in this case, I can still select it is still P. Okay, why? 0.00001, maybe changed by this amount. I can still recognize as the same probability as the first selection. So that's the difference why I can use binomial in this question but not binomial in the previous question. The basic difference is the population number. Do you have a huge population number or a small population number? If it's large, we can assume P is the same for every single selection, and we can use a binomial. All right, so what all this P and X thing represent? Okay, in this question, N will be the sample size. Okay, from this big group, I pick one. Let's say there's 0.6 of the 17-year-old girl who's over 160 centimeters. I select one from this group. What's the probability this girl will be over 160, which is 0.6, right? I know the overall population who's over 160 is 0.6. So I randomly select one. This girl will be over 160 centimeters. Got the chance. We'll get a chance of 0.6. And the next students I'm going to select. Okay, I'm going to select the next one. This girl still have a chance of 0.6 who can be over 160 or not, like 0.6 over 160, 0.4 not over 160. So this is a binomial question. How many samples you select is same as how many trials you're doing. Okay, I'm picking 1, picking 2, picking 3, picking 4. Okay, so this is the sample size. What is the P? Okay, P is the population proportion. Is the population proportion. Population proportion is like, I know that 60% of the 17-year-old girl will be over 160. This is my population proportion. So every time you select one girl, there's 0.6 of the chance who can be over 160. So that's your population proportion. What is X? Number of eligible people. Let's say we use population or items. Okay, so it's the number of eligible ones, like who's over 160. Okay, I'm selecting 10. Each one got this 0.6 of success. How many success? Well, I can say that's a success, or I can say that's what I'm trying to investigate. I'm going to investigate who's over 160. So that's the number of eligible. Okay, number of eligible. So therefore, we have a formula here. P hat will equals to X over N. Your P hat is a random variable. That is decided by what? That is decided by your X, your capital X. Okay, why decide by capital X? Your capital X is how many students are eligible over the total number of students you select. That will give you a sample proportion. And depends on the X change, your P hat will change as well, right? And the X, how X can change? X is follow a binomial distribution. You can find out the probability X is equals to 1, X equals to 0, X equals to 10, X equals to N. You can work out the probability by using the binomial distribution. At the same time, your P hat is the distribution follows X distribution as well, because basically it's X distribution divided by N. Okay, so that's how we can work out the new way. Let's say that's a new way compared to the yesterday's work is another way. Instead of NCR, we use binomial to work out our probability. But what we're focusing on is still the number of success. Can you see yesterday what we focused on is the number of red balls we pick, 0, 1, 2, 3. We use that number to calculate the probability. So today we use the same thing. What's the x that can equals to? And what's the probability of getting that x? And that's the probability of getting that proportion. Oh God, I forgot my charger again. Just have a look. Expect p hat. So p hat is what? P hat will be the eligible items over the total number n. That's what we have is expected p hat is equivalent to x over n. What is n? Is n a variable or a constant? It's a constant. Like well, n will change in different question, but in that question, n will be a constant. Like n is 10, n is 20. So what we will have is yes, 1 over n times a random variable x. So that's expected a times x. Okay, that's expected a times x. What's expected ax plus b? Do you remember that? What that equals to? ax plus b, right? In this case, we have plus in 0, so that's fine. Our coefficient is 1 over n. We can take the 1 over n out. And we have expected x. Okay, remember x is a binomial distribution. The 2 parameter is n comma p. What's expected x? NP, that's right. Expected x, because x is binomial distribution with n and p, so expected x is just NP. And what we have is just p. Expect p hat, well, that's what, do you understand? That should make sense. That's fine. That should be correct. What you expect your sample proportion equals to. If it doesn't equals to actual proportion, why you do it? What's the point you do it? If it's different, why we do sample, you know it's not accurate anyway. So there's no, I don't really need to do that. So if something makes sense, okay, if something makes sense, expect p hat should be expected 1 over n times expected x, and that's 1 over n times np, and that is p. So what you need to remember, in any case, if it's a proportion question, sample proportion question, your expect value of your sample proportion should be equivalent to your actual population proportion p. Now let's have a look at variance p. Variance p hat equals to variance of x over n. Okay, what's variance ax plus b, everyone? What's variance ax plus b? A squared variance x. How about the b? Yeah, nothing. Variance of a constant is 0. So we have a squared variance x. Then in this case, I have 1 over n squared times variance of x. Your a value is 1 over n. Okay, your a value is 1 over n. So that's 1 over n squared times variance x. What's variance x, everyone? X np 1 minus p. Okay, because x is a binomial distribution, variance x will be np 1 minus p. And then you divide that by n squared. What we have is p 1 minus p over n. Okay, what's the standard deviation of p hat? What's the standard deviation of p hat? Square root of p 1 minus p over n. Alright, this is something you need to remember. Okay, two important formula is SD p hat equals to square root p times 1 minus p over n, and expected p hat equals to lowercase p. Two important things you need to remember. But I think if I go through this with you, even though you forget, you should be able to make this out by yourself, okay? Because x is a binomial distribution with n and p hat equals to x over n, and therefore I can go through these steps by yourself, and you will have expect p hat equals to p and SD p hat equals to square root p times 1 minus p over n. You need to remember them, okay? You need to remember them. Let's have a look at the example here. Okay, let's look at example here. Suppose that 70% of 17-year-olds in Australia attend school. Okay, what's the 70%? What amount is that? Yeah, 0.7. What variable is that? Like P. That's your population proportion P. Okay, so in the whole population, you have 0.7 of these 17-year-old Australia attend school. In a random sample of 20, what's 20? N. Okay, and you don't know the total population. See, you are not given the total population here. You don't know how many people are there. So chosen from this population, the probability that the sample proportion, okay, when you see the word sample proportion, that is the p hat, is equal to the population proportion. Okay, in this question, first of all, in this question, you have no idea on the total population. There's no way you can use this NCR. Okay, no way you can use NCR. You use NCR, you need to know the two subgroup. What's the number of that? What's the number of that? What's the total number? So you don't have that information. First of all, you can reject NCR. You can't use NCR. So the only thing you can use so far is binomial. Okay, it's the binomial. So what x, okay, first of all, I need to define the random variable. So let x be the number of 17-year-olds attend school. Okay, let x be the number of 17-year-olds like attend school. X will be what distribution? Binomial with what perimeter? 20, 0.7. Good. N is 20. You have 20 trials. You pick 20 people, and probability is 0.7. All right. What's your p hat in this question? P hat will equal to what? P hat can't be 0.7. An equation. It's not a value. Something divided by something. X divided by 20. Okay, your x is a changing number. X can be 1 student attend school, no student attend school, 20 students attend school, 15 students attend school, 15 attend school. So x over 20 will be the proportion of 17-year-old attend school in that sample. Okay, in a particular sample. Now, what you're looking for A, what you're looking for is probability. What's the probability that the sample proportion is equals to population proportion? What's the value for population proportion? Population proportion 0.7. Okay, so you want to find the probability your p hat equals to 0.7. Now, for binomial, what you need to do is you're not focusing on p hat. You want to know the x value. Okay, you don't care about p hat. What is p hat? I don't really care, but I want to convert from p hat to x, and then I can solve. So p hat equals to what? I have list here for you. Is x over 20, right? That equals to 0.7. So in that sample of 20, how many people attend school will give you a sample proportion 0.7, which is 14 people. Okay, there needs to be 14 people attend school in that sample. then you will achieve a sample proportion of 0.7. What I have done, times 20 on both sides. X equals to 14. So I need to have 14 people exactly attend school in the 20 sample, 20 sample, and I will have a sample proportion of 0.7. So now this question come back to a binomial question. Okay, come back to a binomial question because it's menu 55A. You want 20 trial. Successful rate for each one is 0.7, and you want 14 success now. Okay, you want 14 success. Binomial PDF. Okay, X is a binomial distribution. I have 20 trials. I have successful rate 0.7, and I have a value of 14 here. Have 4 decimal. I think give 4 decimals. 0.1916. 0.1916. Any question for this one? If it's a p hat equals to x over n question, you always convert the p hat into x and then do the calculation. Okay, next one is a very typical question and it's very important. Okay, it's very important type of questions. The probability that the sample proportion lies within one standard deviation of the population. One standard deviation of the population. Okay, first of all, well, you know the population proportion, which is 0.7, right? And also that's the expected p hat. That's the expected p hat. What's the standard deviation of p hat? Square root of, yep, 0.7 times 1 minus p, 0.7 over n. N is 20. Okay, it's the square root of that. Okay, it's the square root of that. Okay, let's just save this number in the calculator. 0 square root of 0.7 times 0.3 p 1 minus p over n, which is 20. Well, control VAR, let's say that number is a. Okay, that's the one standard deviation. What I want, okay, that equals to sigma. And expected p hat equals to p equals to 0.7. So what I want is, I want to find the probability that my sample proportion lies within one standard deviation of the population proportion. Okay, of the population proportion. So population proportion is 0.7 minus sigma, 0.7 plus sigma. Okay, from the mean, go left, go right for one standard deviation. You want your p hat is in between that. Okay, you want your p hat in between that. Okay. So what you have is probability that, well, I will use 0.7 minus a. We get 0.59753. Greater than p, smaller than p hat, smaller than 0.7 plus a. That is 0.80247. Okay, so your p hat, I want to calculate the probability that your p hat is in between that. Okay, your p hat is in between that. Well, what I have done is just calculate the number. Okay, it's just calculate the number, one standard deviation, one standard deviation minus, plus one standard deviation on the right hand side, find the value. I want my p hat, the probability my p hat calculate out needs to be in between that value. very easy idea. This is x over 20 as well. Okay, your p hat is x over 20 as well. Again, I'm going to times 20 on both sides of this inequality. Okay, times 20, 20, 20 on everything. So this number times by 20 have 11.95. That's x. And this number times by 20 have 16.049. Or you can say 16.05, doesn't really matter. Just round it to some decimals. Do not just round to integers. Okay, round to some decimals. Okay. Do you remember what is your x? What's your definition for x? What is x in this question? Yeah, number of 17-year-old attend school, right? In this question is the number of 17 years old attend school. Can you have 11.95 students attend school? No. Okay, you need to adjust that to integer values. What integer value you need to adjust to? What's the integer in between 11.95 to 16.049? 12 to 16. Okay, well, in this question, it's just round up and round down, but it's not actually round up and round down. If this is 19.9, you still take 16.9, you still take 16, not 17. You not think about round up or round down. You think about the integer in between that. Because x is the integer and x is in between that. So what's the integer in between those two values? You will have 11. You can take 12. You can take 12 because next integer after 11.95 is 12. And the thing before 16.049 is 16. So it needs to adjust that to the integer. This is not rounding up or rounding down. It's adjust to integer in between. Okay, so you must remember that's adjust the integer in between those two values. You round up for the first number and you round down for the second number always. Okay, always, because you need to think about the number in between those two values. So now x is a binomial distribution and you want your x's in between 12 to 16. Menu 55B, CDF. You have 20 trials. You have successful each time is 0.7. You have 12 as lower bound and 16 as your upper bound. Then you can achieve a sample proportion is in between that two value. If you use 11, the sample proportion is not going to be in between that value. Okay, it's not going to in between that value. You can have a try. Okay, so that's 0.7796. For decimals, 0.7796. Okay, very important question. Okay, very important question. You need to round to the appropriate integers in between the two values. We have talked about that in binomial section, if you remember. Like it's a similar question like this, and we round to the integer values in between the two numbers. Similar idea here. I don't have much time, so I'll leave C for you to do by yourself. It's just change one standard deviation to two standard deviations. It's exactly the same thing. Instead of using sigma here, I use 2 sigma here. So it's within 2 standard deviation. So I will skip that now and you do that after class. What I'll do is for example 6 and example 7. Okay. Let a random variable p hat represents a sample proportion observed in an experiment. If p equals to 1 on 6, what is the smallest integer value of sample size? Okay, smallest integer value of the sample size. I'm looking for n. Okay, what's the smallest integer value of the sample size? Such that, okay, to do what? such that the standard deviation of p hat is less than or equal to 1/216. So what you want is the standard deviation of p hat. The standard deviation of p hat is less than or equals to 1/216. Okay, that's what you want. That's what you want. My question is, what's standard deviation of p hat in this question? What's standard deviation p hat? Square root of what? What's p in this question? 1/6 times, 5/6, 1 take away 1/6, and divide by n. Okay, that needs to be smaller or equals to 1/216. This is an exam 1 question. Okay, I take this question from an exam 1 paper, so there's no calculator involved, so you need to do that by hand. I'm not going to continue with this now. You can think about that later, just to solve it. Okay, just to solve what you need to do later is just solving for it. And you take the smallest integer value. Okay, the smallest integer value for n. Alright, let's have a look at example 7. This is exam 1 question as well. Okay, this is exam 1 question as well. No cats, which means no cats. Suppose that 80% of all 16-year-olds play basketball. If a sample of size 4 is taken, okay, size 4 is taken, so your n is 4. Find the probability that the sample proportion, okay, the sample proportion p hat lies within and included, okay, within and included 1 standard deviation of the population proportion. Okay, first of all, because there's no calculator, first of all, I want to talk about what's the expected p hat. What's expect p hat in this question? 0.8. Okay, this is 0.8 of all 16-year-olds. So 0.8 is your sample proportion, population proportion. SD p hat equals to what? What's the SD p hat? 0.8 times 0.2 over 4. 0.8 times 0.2 over 4. So what we have here is 0.16 divided by 4, and that is square root 0.04. What that equals to? Square root 0.04, what's that? 0.2. Okay, 0.2 times 0.2 is 0.04. Okay, that's my standard deviation. Find the probability that the sample proportion lies within and included 1 standard deviation. I want to find the probability that the p hat is within and equals to 1 standard deviation. That's what I want. I want my p hat value is in between and within the sample, the population proportion. Go to the left by 1 standard deviation and go right by 1 standard deviation. So that's the probability of 0.6 less than or equals to. This side is 1. What I have here is x over 4. Okay, forgot my x. My x in this question is a binomial question, binomial probability with 4, 0.8. X is the number of 7-year-olds play basketball. Okay, I'm not going to write that, but like you should write that. So x is the number of 16-year-olds play basketball, and x is a binomial distribution with 4 trials and 0.8 success for each time. And I want the probability in my p-hat is lies within and equals to 1 standard deviation, which is 0.6 to 1. Okay, 0.6 to 1. So what I will do after that is times that by 4 on both sides. 2.4. And this side is 4. What's the integer value in between? 3 and 4. Okay, so what I have now is probability x equals to 3 plus probability x equals to 4. That's fine. Tree line delay. X equals to 3 and x equals to 4. So that's the two probability I'm looking for. So that equals to 4 select 3. 0.8. Well, what's 0.8? That's 4 over 5 to the power of 3 and 1 over 5 to the power of 1 plus 4 select 4. 4 over 5 to the power of 4 and 1 over 5 to the power of 0. Yes? Because in between 3 and 4. X is 3 and x is 4. Like probability in between 1 to 4 is 1 plus 2 plus 3 plus 4. Okay, what's N4C3? What's 4C3? What's the n minus 1? Equals to n, so that equals to 4. Okay, n minus 3, NCR n minus 1, that equals to n. Okay, that equals to n. So that equals to 4. That equals to 4. So this is 4. This is 4. And then I have 4 to the power of 3. And then times 4 is 4 to the power of 4. And I have 5 to the power of 4 as well. Okay, that's 5 to the power of 3. And this 5 is 5 to the power of 4. So what I have is 4 over 5 to the power of 4. You see that? This 4 go to the numerator here. And that's a 4 over 5. So overall, that's a 4 over 5 to the power of 4. Just not calculate that yet. Just put it as this first. And what I have here, that's 1. That's 1 as well. So what I'll plus is another 4 over 5 to the power of 4. Okay, so those two probably are the same. What's 4? Okay, 4 to the power of 4 is 16 times 16. What's 16 times 16? Is it? No, 256. 256, right? So we have 256 over what's 25 times 25? 625, and then times by 2. Okay, 1 is 256 over 625, and you have 2 of that. That will times by 2, and that equals to 512 over 625. 512 and 625. Okay, because it's an exam 1 question, you need to know the formula for binomial distribution, and you need to be able to expand that by hand. Okay, not using calculator. And those numbers are possible to calculate by hand. Okay, possible to calculate by hand. And NCR, normally the NCR you will have is N0 equals to NN, that equals to 1. Or N1 equals to NN minus 1, and that equals to N. It's normally will give you those 4 numbers because it's easy for calculation. Yes, N1 equals to N, NN minus 1 equals to N. Or you have N0 equals to 1 and your NN equals to 1 as well. It's normally will give you those 4 numbers because it's easy for calculation. All right, I go through pretty fast today, but I want you to complete example 6 by yourself to work out the value, and I want you to complete example 5C by yourself within the 2 standard deviation. It's a very important type of question. Okay, example 5C. It's exactly the same as example 5B, but just instead of 1 standard deviation, you have 2 standard deviations. And Thursday we'll continue for 17C for the 3rd type of distribution.